Guys, now we will be discussing the inverter operation. So what is an inverter? Previously we discussed the rectifiers. The purpose of rectification is to convert AC into DC. Now the purpose of inverter is to convert DC into AC. We have seen the inverters very much in our daily life. For example, we have seen these in our homes in the UPS system. In the UPS system, we have both types of converters, rectifiers as well as inverters. So we will also discuss this in great detail in future lectures, inshallah. We have a separate CLO for applications, so I will discuss the UPS, its types in future, inshallah. Now first we need to focus on the inverter. Okay, here we can also see that we cannot store the AC, alternating current. So the best way is to convert AC into DC and then store that DC into batteries. So this is how we can store the electricity. So that's why inverters are used. First the AC will be converted to DC and the DC will again be converted to AC. Again, why AC? AC is very much popular. We have AC systems of distribution system. We have all the distribution system, power system of alternating current because of its benefits, various benefits. That is another topic. Why AC? Why not DC? So we are not discussing that thing. That is previous stuff. Okay. According to inverter types of inverters, there are various types of inverters. So first classification is according to the characteristic output characteristic scale wave inverter, sine wave inverter, modified sine wave inverter. Then according to the source of inverter, that is current source inverter, voltage source inverter. Okay, the third type is according to single phase inverter, which is single phase inverter will be half bridge inverter, full bridge inverter, and three phase inverter. That would be 180-degree mode and 120-degree mode. And then according to different PWM technique, simple pulse width modulation, multiple pulse width modulation, sinusoidal pulse width modulation, modified sinusoidal pulse width modulation, and finally according to number of output level, multi-level inverter, regular two-level inverter and multi-level inverter, very popular one. So we will discuss further. Okay. Now according to the output characteristics, the sine wave inverter. So sine wave inverter is an inverter which produces a sine wave from the DC input. So if we supply the square wave to the sine wave based appliance, it may first one is the square wave inverter. So square wave inverter, if a square wave inverter will produce a square wave from the DC. I already discussed in class that the square wave is the most polluted wave in electrical engineering. There is like the air pollution we have in electricity, we have electric pollution. That pollution is in terms of harmonics. So square wave has the maximum harmonics in it. The other form is sine wave. In the sine wave, this is our desirable wave. Or I have given the example of mineral water, that if we want to quench our thirst, we need mineral water. So sine wave will be the mineral water. So that inverter is our requirement. We need a sine wave inverter. If we feed this in sine wave to our appliances, their life will be more. We have seen that in our homes, the life reduces a lot of the equipment like energy savers, fans, because of the scale wave, because of the harmonics, which are detrimental to the life. It's just like us. If we are taking the contaminated water, then definitely our whole our health deteriorates. So that's the same way in electrical energy. Okay. Now this, and a third one is the modified sine wave. So here we can see that this is the square wave inverter, the other one is the sine wave inverter, and this is the modified sine wave inverter. Again, modified sine wave inverter is better than a square wave inverter. So if we are not able to get a sine wave, then we try to get a modified sine wave, so that it will have less harmonics. Okay. The other one is according to the source of inverter, that is current source inverter and voltage source inverter. Current source in inverter means in the source side we have a current source, and voltage source inverter means in the source side we have a voltage source. So that is another classification of the inverters. Now according to the type of the load, single phase inverter, three phase inverter. So single phase inverter which has a single phase load, line neutral, and three phase inverter which has three phase load, right? R, Y, P, red, yellow, blue. In terms of if we have delta connection, then we will be having neutral, otherwise we will be having a delta. Now this is a simple single phase half bridge inverter. Here we can see that there are the source is divided into two portions, Vs by 2, Vs by 2, and we have two switches, T1 and T2 thyristors, and these are freewheeling diodes which are in parallel with the switches for its protection. So in the first half cycle, this T1 will conduct, and we will be having right side plus and left side minus. And in the second half cycle, this is from 0 to T by 2, and from T by 2 to T we will be having this T2 conducting. Now here we on the left side we will be having positive, and on the right side we will be having negative. So this is how we will get an inverted wave across the load. So this is the you can say this is the waveform gate pulse for T1 and gate pulse for T2. When T1 is conducting, we have Vs by 2, and this is the output voltage, the overall output voltage. So this is for the T1 is conducting, the other is for the T2 conducting. So this is how we get a scale wave. Again, this is a polluted wave. It has greatest number of harmonics, and this is the current from the current to the output, I0. I0 is the output current. So this is the waveform of a single phase half bridge inverter. Now the other comes the single phase full bridge inverter. Again, here to note that the output voltage is Vs by 2. So this is the drawback, we are not getting full voltage on the output side. In the full bridge inverter, we will be getting full voltage on the output side. So this is a full bridge inverter. We can see that this is the resistance, and T1 resistance, this is a load basically, T1, T2, T3 and T4. From when when the positive cycle is occurring, T1 and T2 are conducting, and on the other cycle from T by 2 to capital T half cycle, other half cycle, T3 and T4 will be conducting. So this is how we will be getting a scale wave on the output. So here you can see that this is the gate pulses for T1 and T2 conduction, and these are the T5 and T4 conduction. So this is the scale wave we get, and here we are having the voltage Vs, not Vs by 2. So this is the benefit of full bridge inverter, single phase inverter. Please also note that here we can see that if T1 and T4 are accidentally simultaneously get on, then this supply will get shorted. So we have to prevent this thing, that T1 and T4 must not be on at the same time. Similarly, T3 and T2. Okay, so this was all about single phase inverter. We will discuss the three phase bridge inverter in the next video. Thank you very much.